problem. So yeah, we got 3 solutions. Yeah, there we go. Oh, and try to write your solutions out in coordinates. So -1 over 3, comma 0, 2, comma 0, and -2, comma 0. All right, time to use some factor theorem. Let's do this. Oh, here, maybe I should show you how to do this individually. Okay. So here we're using factor theorem. Now, if you don't remember factor theorem from the previous lesson, all you have to do is look for factors of your a value, which is the leading coefficient, your factor of your constant, and was it b over a or a over b? I always forget. Let's see. So let's write first all the factors of 2. So factors of 2 and 1. And remember, there's always a positive and negative relationship, so you can always have positive 1 and negative 1, or positive 2 and negative 2. Factors for 6. Now, the fact that it's -6, it doesn't really matter, because when it comes to all factors, we can have positive and negative. So here we're going to have something like 1, comma 2, comma 3, comma 6, 4 numbers, and all numbers can be positive and negative. So these are all the factors for A and for B. B being the constant term, A being the leading coefficient. All right, once I have that, now it's B over A. So B over A. This is always your constant term divided by your leading coefficient. So let's do that. That's going to be everything over 1. So 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And I'm not going to write the over 1 part because divided by 1 just gives us those values. So there we go. And now all these values except divided by 2. So we're going to have 1 over 2, which is a half. We're going to have 2 over 2, which is technically 1. So we're kind of repeating values. So I'm not going to write that because 2 over 2 is just 1, and we already have that. What about 3 over 2? Though that's a new number, so 3 over 2. And 6 over 2 is 3. And we already have 3 as well, so we don't need to write that as well. So when it comes to all the possible values, 1, 2, 3, 4, 5, 6, and then times 2, so 12 possible factors that we can try using the factor theorem. So let's pick and choose some values to now substitute into this equation and see if any of them give us a value of 0. Easiest number is to always try 1. Plug in 1. And if you're plugging in 1, all you really have to realize is that you're just adding or subtracting the coefficients. Because anything times 1 is just that thing. So 2 plus 3 is 5. 5 minus 11 is -6. -6 minus 6, that's -12. So clearly 1 is not the answer. But always check because, it's easy to do. Next, I always check -1. So plug in -1. And here it's very similar to positive 1, except whenever you have an odd exponent, just multiply that coefficient by a negative sign. Whenever you have an even exponent, just leave it as is. So here we have an odd exponent, x to the power of 1. So multiply -1 with -11, we get positive 11, and we have -6. So let's add these up together. So 3 plus 11, that's 14, and then 14 minus 8, that's not 0. So it's not -1 either. Okay, let's move on to 2. I usually leave the fractions for last because they're a bit more difficult to deal with. So let's do 2, positive 2. Very easy. 2 cubed. What is 2 cubed? 2 times 2 is 4, 4 times 2 is 8, so 8 times 2. 8 times 2 is 16. So 16 plus 2 times 2 is 4, 4 times 3 is 12, and that's going to be 22 because 11 times 2. Let's see if this adds up to 0. And just use a calculator, you guys don't have to do it in your head. So the negative values are -28. The positive values are positive 28. So this is 28 minus 28, which gives us a value of 0. So we finally have our first factor that we can try. So we know that f of 2 is equal to 0, so we can now use factor theorem. We can use synthetic division or long division to do x minus 2. Remember, the b value that gave us a factor of 0 is 2, and x minus b is my binomial that I'm going to divide by. So that's why it's x minus 2 and not x plus 2. Even though the value you substituted into the equation was positive 2, the actual binomial equation is negative 2. So be careful with that. Don't forget that. And now we're going to do long division or synthetic division. I'm just going to do long division. I just like it better. It's a little bit longer, to be honest. A lot of students, from my experience, have told me to prefer synthetic division. So feel free to use that if that's easier for you. So I'm going to be quick. So 2x squared times x is going to give me 2x cubed. And 2x squared times negative 2 is going to give me negative 4x squared. Remember the negative sign there, so subtraction, boom, boom. 3 plus 4, 7x squared minus 11x. So here we're going to have plus 7x, because 7x times x is 7x squared, and minus 14x goes here. So we got a nice subtraction here. 7 minus 7, 0. Negative 11 plus 14, that's going to be 3x minus 6. And here we're adding 3. It's going to be 3x minus 6. And we expected a remainder of 0 because we used the factor theorem initially to make sure that there was a remainder of 0. So here we have two factors, x minus 2 and this bracket here. So let's write that out now. So we have x minus 2 as a factor. And we have 2x squared plus 7x plus 3. That's my quadratic. Once we have a quadratic, we can do a lot of things. We can use quadratic formula. I think that'll give us the zeros, or we can just factor. Let's factor. What's 2 times 3? That's 6. So two numbers that multiply to 6, or two numbers that add. And two numbers that add 7. Oh, that looks like 6 and 1 to me. Yeah, that's an easy one. So x minus 2. This is going to be 2x squared. And a lot of students, unfortunately, forget that the answer is not just x minus 6, x minus 1. You have to decompose the middle term, because this is considered a tricky trinomial, meaning the a value is not 1. So you can't take a shortcut. You have to do it the long way if you want to do it, accurately. And before I write the 2 there, I'm going to now do some common factoring. So 2x can be factored from here, and only 1 can be factored from here. So this becomes, here, let's move this down a bit. This becomes 2x, and that's x plus 3. That's just a plus 1 because the factor is 1. That becomes x plus 3. And we can now just factor these, combining the brackets, since the brackets are exactly the same. And here we have our fully factored form from our initial degree of 3 polynomial. And yeah, that's it. And did they say equal to 0? Yeah, since they did mention an equation equal to 0, we need to now write solutions. So x is equal to 2, or negative 3, or negative 1 over 2. These are the answers. They did synthetic division, which is fine. And they found out that x minus 2 is a factor because it substituted 2. And they figured out that x plus 3, x2, x plus 1 is fully factored form, and the final answers. And what do your answers in part A represent? Well, the values of 2, negative half, and negative 3 are roots of the equation, which means there are x-intercepts of the graph of the function. That's it. Pretty straightforward. Let's move on now to an example of degree 4 polynomial, and let's factor this out. So a lot of the same things happening for this lesson, just a lot of practice. Here we have our leading coefficient of 1. Which makes our lives, a lot easier, because we just have to look for the factors of 12 now. We don't have to kind of divide b over a, since a is 1, and if you divide by 1, it's just the same value. So what are factors of 12? Well, we have 1 and 12. We have 2 and 6, 3 and 4, and 4 and 3. Since 3 and 4 and 4 and 3, they're repeating, all factors have been accounted for here. So we have 6 factors. And remember, there's always a positive and a negative sign in front of all of these factors. So let's actually get rid of that box. Let's write it out properly. So positive 1, negative 1. Let's try 1. You have 1 minus 2 minus 7 plus 8 plus 12. 8 plus 20, and then that's minus 9. No, that's not going to be 0. So 1's not the value. Let's try negative 1. So same thing, except remember, even exponents leave the... oh, shoot, I'm going to plug in my laptop. It's going to die. There we go. All right. Okay, so yeah, so 1, even exponents leave the coefficient alone. Odd exponent, multiply the coefficient by negative 1, so that's going to be positive 2. Leave the negative 7 alone, that's going to be minus 8 plus 12. Okay, let's see. Well, here we have minus 15. And 1 plus 2 plus 12 is 15, so 15 minus 15 is 0. So our first, I should have wrote it in function notation, but the first value that we substituted in, they gave us a value of 0, is negative 1. Meaning our binomial is going to be x plus 1. And our polynomial is here. Okay. Sorry, oh, my hand is getting a little crampy. Sorry. All right, so x cubed times x, that's x to the 4 plus x cubed, minus sign there, so minus minus 3x cubed, bring that down, that's going to be minus 3x squared, 3x cubed minus 3x squared, the minus sign here, these all become plus plus, cancels out. My negative 7 plus 3, that's going to be a negative 4x squared plus 8x. That's going to be minus 4x. So that's minus 4x squared minus 4. Negative sign here. These become positive. Cancels out. 8 plus 4 is 12x plus 12. And this is going to be plus 12. So that's going to be 12x plus 12. 0. Okay, so remainder of 0, which is what we wanted because we used the factor theorem. That's the whole reason why we're dividing. So now we've reduced our polynomial to a degree 3 polynomial. So let's do that now. At this point, we can now substitute values into this equation and try the factor theorem using this, or we can continue using the factor theorem here. It doesn't really matter. I think it's easier to do the degree 3 because there's less terms. So let's redo the factor theorem now for this new polynomial. The factor is 12, so it's still the same numbers. So we can try 1 again. Oh wait, sorry, I apologize, I should mention. If 1 wasn't a factor in the initial, it's not going to be a factor in the later parts either. Because it's the exact same equation, it's just being factors, being simplified, right? So 1 we've already tried, and we tried negative 1 as well. We could try negative 1 again, because it's possible to have a negative 1 factor twice. So we could try negative 1 again. So let's try negative 1 again. So that's just going to be negative 1, because it's an odd exponent. Negative, leave that alone, minus 3. This becomes plus 4, plus 12. So you can see that 16 minus 4, that's not going to be its value of 0. So it's not negative 1 again. Next up is 2. Let's try 2.